Nice to see you all. Let's start. And yes, the title says the best architecture, and I know exactly how that sounds. So let me diffuse it right away. By best, I do not mean a silver bullet. I mean a compilation of clean architecture, industry best practices, recommendations from Google, JetBrains, and my own production experience, filtered through Keith and Yagni. And the second half of the title matters just as much. Today I will also show you exactly when you should not use the architecture. That part is usually missing from architecture talks. Briefly about me, I'm Pavel, almost 20 years in development, 15 years in mobile development, worked in startups and in large international companies. Now I'm a mobile team lead in 2U. This QR code links to my LinkedIn. I wrote 2 articles on Medium about the approach I'll be sharing today. Open template repository with source code, and these articles are linked on the final slide. Kotlin Multiplatform can compile your code for Android, iOS, desktop, web, and backend. And Compose Multiplatform adds shared UI on top. So technically, you can share almost everything. And that is exactly the trap. And it has 2 failure modes. Share too much, and you fight the platforms daily. Glue code, workarounds, UX flatten it to the lowest common denominator. Share too little, and you write the same business logic twice, with 2 sets of bugs slowly drifting apart. So the right question for a product that has to live for years is not how much can we share, it is where should we stop. This talk is about where that line goes and why it moves depending on your project. What I demand from a best architecture? It's simple, Keith and Yagni at the core, fast onboarding, readable reviews. It's powerful, full access to each platform's native capabilities. Cost-effective, shared code compiles into target-specific artifacts. GM bytecode for Android, native binary for iOS, with no handwritten platform channels and no runtime reflection. It's extensible. A new platform is a project, not a rewrite. And practical. The boring essentials, unified error handling, offline, and cache dependency injection are solved once. Pagination, token refresh, and login are implemented in the template too. I just will not have time for them today. As a basis, we will use clean architecture. The KMP shared module is limited to data and domain, repositories, database, network, use cases. ViewModel and UI are never shared. The only thing the native world sees is use cases returning domain entities. Android renders Compose, iOS renders SwiftUI, and each team picks its own presentation pattern. On one project, Android team can run strict MVI, while iOS uses classic MVVM, and nobody is anybody's way. And yes, this means I advise against Compose Multiplatform as the foundation of a large, long-lived product. Let me defend that. I honestly waited for years for shared view models because the idea sounds perfectly logical. But the main argument against them is architectural, not technical. A ViewModel is the top of the presentation layer, and presentation is exactly where Android and iOS differ. Lifecycle, navigation, UX idioms. Jetpack ViewModel is designed around the Android lifecycle. On iOS, Google's own guide has you wiring a ViewModel store owner by hand, and this concept means nothing there. Sharing the ViewModel forces one architecture onto both platforms, and at the very layer where they deserve freedom. On top of that, there is a technical tax. With plain Objective-C, experts SwiftUI cannot observe Kotlin flow directly. So teams write wrappers and adapters and bind coroutine scopes manually. SKIE removes much of that tax, but it doesn't remove the architectural argument. TouchLab, who built half the KMP iOS tooling, recommends the same split. Share your models if you are all in on Compose Multiplatform. And with the native iOS UI, e-presentation platform specific. Of course, healthy exceptions exist. Backend-driven UI and isolated features are a natural fit for Compose Multiplatform inside a native app. And navigation also stays native. Consistency comes from the shared data, not a shared navigator. Now, the organizational part. A common problem when introducing KMP into an existing team is a resistance of iOS developers. Understandably, they are being told their habits are now second class. The use case boundary reduces that friction a lot. iOS developers can write in SwiftUI however they like, with whatever presentation patterns they like, and the only change for them is that they get data from a use case instead of building their own networking stack. And because the common core has no Android framework dependencies, it's pure Kotlin. iOS developers can read it and pretty soon write it. Models, API, repositories, and are language-independent concepts. With this on my project, the entire technical onboarding fit into 3 documents: the architecture, the file structure, and how to add a new feature. Simpler is better. When data and domain are multi-platform from day one, extra targets get cheap. 3 bonuses. First is desktop. A large part of the Android Compose UI can be used there. What remains is adapting layouts and packaging installers, far cheaper than a separate desktop app. Second, my favorite, a backend on shared models. Your DTOs are already serializable, and a cater server is just another JVM target. The template wrapper ships mock backend answering with the exec type the app process. Endpoints and server behavior can still diverge, of course, but schema drift becomes a compile time problem instead of a production surprise. And it unblocks mobile development while the real backend is still being built. And third, web. A web team can consume a shared logic as an npm, a package through Kotlin.js, and Quizlet has run that pattern in production since 2019. And Compose Multiplatform with Wasm already works for internal tools right now. So much for our strategy. Now let us see what this looks like in code. If we have a chance, of course. Yeah. The practical half starts with the data flow because maybe it's because of the cable. Don't touch. Okay. The practical half starts with the data flow because everything else sits on top of it. The template project implements two variants. For screens that must update live, the reactive variant, classic offline first. The database is a single source of truth. The UI collects the flow from it, and the repository coordinates the database and the network. A background refresh writes new rows, and the screen updates itself. The UI never renders a network response directly. For simpler screens, one short pattern is enough. Try the network and return the fresh result, or on failure, serve the cache with an isOld data flag, so the UI can whisper this data may be stale. And notice, all of this is pure Kotlin, not a single platform API involved. Now the boundary. The use case sits between two roles. And today, Kotlin reached Swift through an Objective-C export, where a lot is lost in translation. The Kotlin Swift Encyclopedia catalogs the damage. JetBrains is building Swift export, direct export without the Objective-C step, but it's still in alpha. So we can control, and we control the damage by contract. Use cases return only domain entities wrapped in a domain result or flow of them. Simple type cross the border safely. Exotic ones do not. Two classic traps illustrate why. Trap number one, sealed classes. In Kotlin, sealed hierarchy plus exhaustive when is a superpower. But through Objective-C, it degrades into an ordinary class hierarchy. Swift knows nothing about sealedness, and exhaustive switch is impossible. So you have to write chains of casts with a mandatory else branch. The dangerous part here is adding a third case on the Kotlin side. This Swift code keeps compiling. The new case quietly falls into else. You find it out probably through a runtime bug instead of a compiler error. In Kotlin, the compiler would have stopped you. But we will get that guarantee back in 2 slides. Trap number 2. Why not just use Kotlin result? Because the Objective-C export erases value classes and Kotlin result reaches Swift as a useless any. That is a long-standing UTrack issue, KT32352. So we define our own sealed domain result. Success carries the value plus the isOld data flag that we saw in the single set of truth slide. And failure carries a typed up error instead of a row exception. Object name annotation gives it friendly Swift spelling. So every use case in the project returns this type. One convention, no surprises at the border. And here is the tool that makes the boundary feel native. SKIE by. And the last but not the least, never let a custom exception escape from a flow crossing into Swift. Cancellation is handled for you, but your own exception will not become a Swift error, and it will crash the app. Catch failures inside and emit domain result. Some words about error handling. Errors get their own contract because Kotlin's throwable and Swift error never map cleanly into each other. The whole app speaks one fixed set, a sealed up error hierarchy. HTTP statuses, technical failures like timeouts, and pure domain errors like form validation, all in one multi-platform type. But where do they come from? Every network call goes through one function, SafeIP call, which maps statuses and exceptions into domain result failure. And importantly, throws cancellation exception, so structured concurrency keeps working. Then classification. Shared error handler turns an up error into an error side effect, a tiny sealed set of UI intentions. Transient errors show something dismissible. Session expired, clear everything and go to login. And ignore, do nothing. As a default handler encodes your UX guidelines once. Context-sensitive decisions like that can use a custom handler injected through DI. And as a result, the giant when over every error disappears from screens. The ViewModel keeps a tiny switch over side effects. Dependency injection, coin. It's closer to a service locator than Hilt, but it's predictable and truly multi-platform. The whole graph is assembled inside a shared framework in a way any Android developer recognizes. For iOS, we have 3 steps. Register the use case in the common module, expose ready instances to a coin injector object, so coin types do not leak into the generated header. And on the Swift side, wrap the use case in a protocol. That is what buys the stability. A unit test substitutes a mock with the same signature. No DI framework needed on iOS side at all, but of course you can use any if you want. The alternative would be constructing Kotlin object graphs by hand in Swift and marking half of shared framework as public. I think nobody would love us for that. Modularity. Network, database, analytics plus feature models, each with its own coin module aggregated by root. In large companies, the core belongs to a platform team that writes and tests it once. It's a trade-off everyone asks about. iOS receives all of shared module as one umbrella framework. For modules that exchange shared Kotlin types, that is usually the practical option, not a defect, because Kotlin native compiles closed word, so separate frameworks each carries their own runtime, and identical Kotlin types from different frameworks are binary incompatible. Separate frameworks make sense only for genuinely independent SDKs. Testing in practice, use cases and repository implementations are covered by ordinary JVM tests with MoPK and Keratin's test. A full run takes seconds and exercises exactly the logic that ships to every platform. Cover plugin measures coverage on the JVM target, which precisely the part we care about, and CI gate blocks merged below the threshold, let's say 80%. Documentation follows the same philosophy. Docker plugin generates a reference of business scenarios as a CI step, and a documentation skill for your AI agent helps keep the KDoc fresh before review. Of course, it doesn't guarantee perfect docs, but it removes the nobody remembered failure mode. And now the second half of the title. When should you not build any of this? Let me tell you about my pet project. There is a wonderful crew in Cyprus called Ecambara. They plant trees using technology genuinely innovative for the island. And they needed to track plantings, organize watering events, and register volunteers. I web-coded them a backend, a Telegram bot, and mobile apps, and did everything backwards. KMP+CMP, shared UI included, no clean, no layers, not a single unit test. Just code you can write fast, ship fast, and rewrite fast. And that was the right engineering decision, in my opinion, not a guilty shortcut. We had no clear requirements, only one developer and zero budget. Case number 2. There is simply nothing to share. Platform widgets, small utilities, thin online-only clients with little client-side logic and no cache. Data and domain layers, there are pure boilerplate. And case number 3, the app that will barely evolve. For example, a restaurant app with a fixed feature set does not need an architecture built for decades. And note, even in these cases, KMP keeps you a migration path if your project unexpectedly grows. One thought to take home. KMP is not a right answer on everywhere. It's about sharing exactly what makes sense to share and not a line more. For large product, clean in KMP, shared data and domain, native UI, use cases as the contract. For startup experiment, Compose Multiplatform everywhere, because speed beats structure. Mostly UI and no data, just go native. And between these options, there is no chasm. There is a staircase. When your startup grows up, you replace the iOS UI incrementally while keeping the share code. The presentation layer changes, the investment in data and domain survives. No full rewrite. So the question is not KMP or not. It is where on this staircase is your product today. Look at it honestly and either start climbing or deliberately stay where you are. Both answers are valid when they are honest. Template and both articles are behind these QR codes. Thank you, and please ask your questions.